4 billion miles away from the Sun, Pluto is doing something that sounds almost impossible. Its own atmosphere may be helping the dwarf planet lose heat, turning a thin layer of haze high above the surface into something more like a natural cooling system. For decades, Pluto was treated as a tiny, frozen world sitting at the edge of the solar system. It was discovered in 1930 and quickly became famous as the ninth planet. But scientists had very little idea what its surface actually looked like. From Earth, Pluto was nothing more than a faint point of light. That changed dramatically in 2015. After traveling through space for more than 9 years, NASA's New Horizons spacecraft finally reached Pluto. The spacecraft had only one opportunity to study the distant world up close. It flew past at tremendous speed, collecting as much information as possible before continuing farther into the Kuiper belt. What New Horizons discovered was completely different from the dead, featureless ice ball many people had imagined. Pluto had enormous mountains made of water ice, vast plains covered in frozen nitrogen, strange reddish regions, and a huge bright formation shaped somewhat like a heart. Some areas appeared surprisingly young, suggesting that Pluto had experienced geological activity long after its formation. High above the surface, New Horizons also revealed layers of bluish haze stretching through the thin atmosphere. At first, the haze looked like little more than a beautiful feature in the spacecraft's images. But scientists soon realized it could be much more important. To understand why, researchers needed to study Pluto's atmosphere in a completely different way. A spacecraft takes photographs, but the James Webb Space Telescope can do something photographs cannot. It can analyze infrared light and separate that light into different wavelengths. Those patterns allow scientists to identify chemicals, study temperatures, and investigate how an atmosphere behaves. This became especially important because Pluto is incredibly faint from Earth's perspective, and its largest moon, Charon, appears very close beside it in the sky. Earlier telescopes struggled to separate the faint signals coming from Pluto and Charon. Webb's much more sensitive instruments provided scientists with a better opportunity to isolate Pluto's own infrared signature. Beginning with observations made after Webb became operational, researchers were able to investigate Pluto's atmosphere with greater precision. And one of the most interesting results involved the haze that New Horizons had photographed years earlier. Scientists already knew that Pluto's atmosphere contains methane and other hydrocarbons. Sunlight can break these molecules apart high above the surface, allowing them to form increasingly complicated particles. Those particles eventually become part of the haze surrounding Pluto. But researchers had another question. What does this haze actually do to Pluto's climate? One proposed explanation suggested that the haze might have an unusual cooling effect. Instead of simply trapping heat like a blanket, the particles could absorb energy and then release it as infrared radiation, allowing heat to escape into space. That would mean Pluto's haze is not merely hanging in the atmosphere. It could actually be helping regulate the temperature of the world beneath it. Recent observations have provided evidence supporting this idea. The result is one of the strangest climate systems scientists have encountered. Pluto is already extremely cold because of its enormous distance from the Sun, but its atmospheric haze may make the situation even more unusual by actively helping the planet-sized dwarf world lose energy. And this discovery raises a much bigger question. If a thin atmospheric haze can influence Pluto's temperature so strongly, could similar processes be occurring on other distant icy worlds? That possibility matters because Pluto is not alone in the outer solar system. Beyond Neptune lies the Kuiper belt, a huge region filled with frozen objects left over from the early formation of the solar system. Pluto is simply the most famous member of this distant population. The story becomes even more interesting when we look at what happens to the chemicals created inside Pluto's atmosphere. Methane molecules can be broken apart by sunlight. Their fragments then react with one another and form heavier organic compounds. Some of these compounds eventually become reddish-brown particles called tholins. The possibility of a hidden ocean beneath Pluto's surface becomes even more interesting when we consider what is happening on the world above it. Pluto's atmosphere is slowly escaping into space. Light molecules such as methane can rise through the extremely thin atmosphere and eventually drift beyond Pluto's weak gravitational hold. But some of that material may not simply disappear. Pluto and its largest moon, Charon, are locked together in an unusual gravitational relationship. Instead of one body simply orbiting the other in the familiar way we see with Earth and the Moon, both objects move around a shared point between them. Even more unusual is the fact that they always keep the same side facing one another. That strange relationship may also connect their surfaces. Charon is roughly 750 miles across, and much of its surface is covered by old water ice. But its polar regions have a noticeably reddish appearance. For years, scientists have considered whether material escaping from Pluto could eventually reach Charon. The idea is surprisingly straightforward. Methane escaping from Pluto can travel across the space separating the two worlds. Some of those molecules can encounter Charon and become trapped by its gravity. When they reach an extremely cold polar region, they can freeze onto the surface. Then sunlight eventually returns. Ultraviolet radiation can break apart the frozen molecules and transform them into more complicated compounds. Over extremely long periods, those compounds can contribute to the reddish material covering parts of Charon. In other words, Pluto and Charon may not be completely separate worlds chemically. They could be exchanging material across space. And Charon has provided scientists with other clues about its history. Observations have identified frozen carbon dioxide and hydrogen peroxide on its surface. These chemicals offer evidence that radiation and impacts have been changing the chemistry of Charon's surface over enormous periods of time. The discovery adds another layer to the story of the Pluto system. What initially looked like a tiny frozen planet with a simple moon is actually a complex pair of worlds interacting through gravity, sunlight, chemistry, and escaping atmosphere. Now imagine standing on Pluto itself. The sun would appear incredibly small compared with how it looks from Earth. It would still be bright, but its warmth would be almost meaningless at such a huge distance. The sky would not look like Earth's blue daytime sky. Instead, the thin atmosphere and suspended haze would create a dim, unusual environment. The surface would be unimaginably cold. Water ice would behave much more like solid rock than the slippery ice we know on Earth. Nitrogen could exist directly as frozen material across the landscape. And there would be almost no atmosphere to protect or support a human visitor. Above the horizon, Charon would remain fixed in the sky because of the tidal locking between the two worlds. The view would be unlike anything humans have ever experienced. But Pluto's surface becomes even stranger in certain regions. New Horizons discovered tall, blade-like structures made from frozen methane. These formations rise dramatically above the surrounding terrain and appear in long, organized patterns. Scientists have compared them with unusual ice formations on Earth called penitentes. On our planet, penitentes can form when sunlight causes ice to disappear unevenly, gradually leaving behind sharp ridges. Pluto may produce a similar process, but under completely different conditions and involving methane ice instead of ordinary water ice. Because Pluto's environment is so cold and its seasons last for extremely long periods, these processes can continue for enormous stretches of time. The result is a landscape that looks almost alien even by planetary standards. Elsewhere, Pluto contains enormous dark regions coated with reddish organic material. These areas may represent some of the oldest exposed terrain on the dwarf planet. Then there are the mountains. Some rise many thousands of feet above the surrounding surface, and certain peaks contain deep depressions near their tops. Their unusual shapes have led scientists to consider cryovolcanism as a possible explanation. If these structures really are cryovolcanic, then Pluto once had enough internal energy to push material from beneath its frozen crust toward the surface. That raises another important question. Where could that internal energy have come from? Pluto formed billions of years ago, and radioactive elements inside its rocky interior could have produced heat over immense periods of time. Even though Pluto is tiny compared with Earth, its interior may not have cooled as quickly as scientists once assumed. That possibility is important because a warm interior could potentially maintain liquid water beneath the surface. A buried ocean would be completely isolated from sunlight. It could sit under many miles of frozen material, protected from the extreme conditions of the surface. Scientists already suspect hidden oceans beneath several icy moons elsewhere in the solar system. Europa, for example, is believed to contain a large ocean beneath its icy shell. Enceladus also has strong evidence for subsurface water and even releases material from its interior into space. If Pluto has a similar hidden reservoir, it would demonstrate that liquid water can survive inside surprisingly small and distant worlds.